Hello students, let us see this question here. A car moves with speed v on the horizontal circular track of radius r. A head-on view of the car is shown in the figure. The height of the car's center of mass above the ground is h, and the separation between the inner and outer wheels is d. The road is dry and the car does not skid. Okay, the maximum speed of the car have without overturning, or you can say this is the question of the toppling, you can say. So if you'll see, so suppose this is the center of mass here. Okay. Okay, so when it is about to topple, so let us take the case of about to topple or about to overturn. Right. When the car will be right, when the car will reach at the situation when it is about to overturn, at that situation the car will have the maximum speed. So when it is about to overturn, in this situation, car will have maximum speed. So in order to find the maximum speed, I need to solve this question when the car is about to overturn. So let us solve this. Okay. So when the car is about to overturn, okay. So if you'll see here, the friction will act, right? Since it is moving in forward direction, or you can say since it is moving with velocity v about the center, or you can say the car is moving in circular motion, so it needs the centripetal force, and the centripetal force will be provided by the friction. So let us assume the friction is acting like this. All right. So now the car is having only the translational motion, it is not having the rotational motion. So the net torque about any point will be 0. So if I take about the center of mass, so about the center of mass also the net torque should be 0. So I can say about center of mass, torque total should be 0 because it is having only the translational motion. So mg is passing through the center of mass, so you will get no torque due to the mg. You will get the torque due to the friction and the normal. So due to the friction, you will get the torque F into h, because the center of mass height is h here, so F into h. So torque due to friction plus torque due to normal, that must be equal to 0. Okay. So you can say, okay, so now I can say torque due to friction, that will be Fh, and this will be in this direction, so that will be clockwise direction. So I can take here clockwise direction and negative, and anti-clockwise direction if I take positive. So this will be, now due to the normal, so the total torque has to be 0, and since it is about to overturn, then the normal will pass through the edge like this. Okay, so now the distance of the normal from the center of mass is d by 2, so that will be n d by 2. Okay, right, and obviously the normal will give the torque in anti-clockwise direction, so that will be positive, then only it can be add up and can become 0. Okay, so that will be equal to 0 here. So from here I can say now the friction is providing the centripetal force, so I can say the friction will be equal to mva square upon r. So I can substitute the value of friction here in this equation. So, or you can say n d upon 2 is equal to fh. Okay, so from here I can say I need to find, so I will replace the value of friction here. So n d upon 2 is equal to mv square upon r, that is the value of friction, into h. All right, and the value of n is equal to mg. So from here I can say that will become mg d upon 2 is equal to mv square h upon r. Okay, so the m will get cancelled out, and from here you will get z d r upon 2h root is equal to v. So this is the value of v you are getting when it is about to overturn, and in this situation whatever the speed is there, that will be the maximum speed. So this will also be v max. Okay, so let us see which option is matching here. G dr upon 2h root, so that is the option A. Okay students, I hope you understood this question.